All right, this is the second half of Geometry Chapter 10 review for the final. We're talking about area in Chapter 10, and we've jumped through to circles and then the geometric probability. We kind of jumped ahead a little bit here. So this objective is that students will be able to find the circumference and arc length. So let's find the circumference, leave your answer in terms of pi. There were two formulas we talked about for circumference. One of them was in terms of the radius, and one of them is in terms of the diameter. My preferred method is the radius because all of the other formulas use the radius. So that's all I'm going to use here. So essentially I just have to get the radius for my circles. The first one, I have 22 all the way across. Remember the radius is only halfway across. So I just have to cut that in half. I get 11 and then I just go circumference equals 2 pi times 11. Multiply my 2 and my 11, I get 22 pi. Now it says to leave my answer in terms of pi, so that's it. Now, circumference is a measurement, so it should have a label. Circumference is technically how far around the circle is, so that's like the perimeter. So when we give our label, we're going to give it meters, but we actually don't square that meters. We just leave it as meters, and that's it. You pause the video and try the next one. And we get 13.6 pi meters for that second circle. So that's just your straight up circumference. Okay? After that, we started to talk about area. Area of a circle. So students will be able to find area of circles, sectors, and segments. So circles is just pretty straightforward. Area equals pi times the radius squared. So we got the same picture of a circle. It says find the area of each circle. Leave your answer in terms of pi. So I go area equals pi. Well, I need the radius again. Radius, remember, only goes halfway across. So that's going to be 11. And I go pi times 11 squared. Figure out what 11 squared is. 121. I get 121 pi, and it just wants me to leave it that way. Now, area is a space. It's two-dimensional, so I do need to give it a label. I go meters, and since it's two-dimensional, I square it. And that's it. Where things got a little bit more complicated is finding area of sectors, segments, and random portions of a circle. So that's what we're getting into down here. It says, find the area of each shaded portion of the circle. Leave your answer in terms of pi. So this right here is what we refer to as a sector. It's like a piece of the pie. So what we do is we take that area formula, pi r squared, and we multiply it by the arc measure out of 360 degrees. So if you look at that, well, I can see that radius is 4, so I go pi times 4 squared. And then I have times something out of 360. So that arc measure is the measure of this arc right here. It's the same as the central angle. Well, it's 90 degrees. So I go 90 out of 360 times pi times 4 squared. It wants me to leave my answer in terms of pi again. So I'm just essentially going to take 90 divided by 360 times 4 squared and tack a pi onto it. So I can type all that into my calculator at once. I go 90 divided by 360 times 4 squared, and I get 4 pi. It is an area. There isn't a label here, so I give it units squared. Okay. We got into some of these weird shapes where we had certain portions shaded and certain portions not. So on this one, what we need to do is we're trying to find the space between the circles. So we need to actually find the area of the big circle here and the area of the little circle. So big. It's pi times the radius squared. Well, it's 12 all the way across, the radius is 6. Little is pi times radius squared again. It's 8 all the way across, so the radius is 4. And I figured those out. I'm leaving everything in terms of pi, so I go 6 squared, 36, tack on a pi, and I go 4 squared. That's 16, and I tack on a pi. But I don't want the whole thing. I want the big with the little taken out. It's like a donut. It's got an empty center. So essentially, I just take the big part, 36 pi, and I subtract off the little part, 16 pi. Since they both have a pi, I can subtract the numbers out in front. 36 minus 16 is 20. And I tack on my label with it. I get 20 pi. I've got meters, and it's an area, so I square it. And that's it. After that, we moved on to geometric probability. So it says students will be able to use segment and area models to find the probabilities of events. So the point on AM is chosen at random. Find the probability that the point lies on the given segment. So when we did this, what we needed to know were two things. Number one, how long is the entire segment? And number two, how long is the segment I want? So the whole segment AM. To figure it out, you take the last number minus the first number. So I'm going to go 12 minus 0, and I get 12. Now, DJ, I do the similar thing. It starts at D, it goes to J. I go 9 minus 3, and I get 6. But to find the probability that I land on DJ, I take that 6 DJ divided by the whole thing 12, and I simplify. You can write a probability three ways. You can write it as a fraction in simplest form, as the decimal equivalent, or as the percent. And you need to be able to know how to go back and forth between those. Remember, to go from a decimal to a percent, you move the decimal 2 places. Pause the video and do the same thing with BL. I get BL to be 10. I go 10 divided by 12, simplifies to 5, 6. Get 0.83 repeating, or 83%. Okay, so after that we talked about some area models like this. It says a point in the figure is chosen at random. Find the probability that the point lies in the shaded region. So you actually might have seen these specific problems before. When we have a circle like this and we have the degree of a sector, you want to think about, well, how many degrees is the whole circle? 360. And you can sit here and you can find the area of the sector and you can find the area of the whole circle, but essentially what's going to end up happening is you're going to take the angle measure divided by all the degrees in a circle. So essentially you just want to take that 108 divided by 360 and simplify. So I go 108 divided by 360, and that simplifies down to 0.3, which is the same as 3/10, which is the same as 30%. And it's pretty straightforward there. What gets a little bit trickier is this one over here on the right. You need to find out the area of the shaded region, the area of the rectangle, and the area of the circle. So let's start with the rectangle. You can see it's just base times height. We go 8 times 6, we get 48. Let's go next to the circle. We have a circle. The trick is to find the radius. So I go up maybe. I can see actually the circle is 6 units tall over here, which means the radius has to be 3. So I go pi times 3 squared, and I get 9 pi. Now to find the area of the shaded region, you can see the shaded region is the rectangle part without the circle. So you just essentially take the rectangle part, 48, and you subtract out the circle. Well, it's the probability, not just the area of that. So you might as well, in the same step, take it and divide it by the whole thing. Remember, probability is what you want out of what you have. Well, I have 48 units total. I'm going to divide that by 48. And then you just want to go to your calculator. When you type this in, make sure you put 48 minus 9 pi in parentheses. Divide it by that 48, and we get something that's about 41%, or 0.41. If you really want it in a fraction, there isn't really a fraction equivalent to that because you have an irrational number pi. So these would be the best ways to leave your answer. So that was the Geometry Chapter 10 final review for Semester 2. End of the second and last video.